hello, and welcome back to another episode of Whether or Not. This is episode 11. We're doing a little kind of a part 3 epilogue for Hurricane Milton. A few extra things have come to light and a few new ways of seeing something. Some data actually looks more interesting. So I'd like to welcome to the show John. Hello, John.
Hello, good evening. Thanks for having me on.
It's an absolute pleasure. And of course, he's old part of the furniture. Jeff, how you going, mate?
Yeah. You have a great way with words, Stella. I'm doing great.
Excellent. That's good. All right, then. I'm not going to banter on too much because nobody wants to listen to me fluff on. So I'm going to pass it over to you, Jeff, and you show us or tell us what we're going to be looking over tonight or today. And
Okay.
Over to you.
Sounds good. So I have a PowerPoint type thing set up here, and it's basically the enhanced data with a lot more stations than I was able to do manually with John's help. John came in and kind of like offered up this stuff, and it's like, whoa, what we got now is like we can watch stuff, lots of stations, and get beautiful graphs. So you'll see those in just a second. So Milton, what were you? Were you a hurricane? Were you a tropical storm? Cat 1, 2, 3? They called for 3.
It's an
That was the
identity
path.
crisis.
Yep. Identity crisis, yeah. They said it was a 3 as it hit shore, and it went inland before it dropped down to a 2, and then it dropped down to 1 halfway across the state, and it continued as a 1 all the way across. We did not see that in the numbers. That's where it came ashore, just south of Tampa. That's the radar picture at approximately 0 Zulu, 10th of 0 Zulu, and that UTC time again. So pretty big rain bands to the north, nothing to the south. Okay, so in the previous video, we showed how we started using the aircraft reconnaissance data to track the progress, and NHC, National Hurricane Center, their forecasts based on it. And it was pretty good correlation until the very end. And it wasn't such a great correlation at landfall. So just shows where National Hurricane Center has a website, and we go into data and tools and aircraft reconnaissance, and you go into archive data, and then I'm showing the data here and the location of both aircraft. And this data, which we're not going to go into in detail again because I already showed you guys how to break it down with the codes. But what this boils down to is, as this Teal 73 C-130 was right offshore doing its crisscrosses just before it hit Tampa Bay, it's showing its altitude here was about between 9 and 18,000 feet. The bulk of it right at more like 10,000 feet. That's in the code. It tells you that. It tells you the wind speeds, and you can't really see the numbers that great here. I could blow it up a little bit, but it's kind of not important. It's 106 at 10,000 feet, and 106 knot maximum at that time, 10th at 0018 Zulu UTC. And the altitude was 2915 meters, 9,600 feet. The other aircraft was the P3 Orion, and that was doing the same thing out there. And that was 105 knots, so great correlation. And this was a little lower at 7,700 feet.
Okay, may I just interject in here for a moment? Let's just get exactly understood what we're looking at here. So in the middle there is the flight path of the plane.
Mm-hmm.
And what was the date that we're checking this out at the moment?
This is right at the turn of the day, around 10 Zulu. So this is a little bit earlier for that observation of the minimum or the maximum wind is what I picked right there. So at 09 2306, the other aircraft was crossing through that center point at a different time. It was right after 10, which is, if I go back up one, that was at 10:18. So in that hour, they were both crossing that center point at different times.
Hmm. And everything correlates?
105, 106 for max winds. So
With each other?
Yes,
Yep.
with each other, they correlated beautifully.
Yep.
Yeah.
Okay. All right. Thank you.
Okay, so that was the winds aloft versus winds at the surface. That's going to be shown next. So those previous winds were at aircraft altitudes. I said above 1,000. One was a little below, so around 10,000 feet. And the surface winds are showing here. And we went to the FAA surface weather observation stations, which I showed you when we did Helene. I showed you how to get this data by clicking on a state, and then you get access to all this data. So I was doing that individually. So when John sent me the Excel based on him, he can describe this himself shortly, but he basically sucking the data out of all those stations that were listed right there. And I can't tell you how many there were here, but this is an Excel sort showing the highest wind speeds. This is the top wind speed that was seen, 60, and everything else is lower. And 60 correlates to tropical storm strength. And this is, I'm going to show you two more screens. That's the bottom of the highlighted area, which I had a sort stopping at 34. So this is 267 lines in of winds 34 knots or greater, not exceeding 60, all tropical storm strength. And when you do the math, there were 3,101 lines here. That math, 267 of 3,101, 8.6 of all the observations, and those are like sometimes a half hour apart, sometimes an hour apart, with a mix of all these stations right here. These are showing the stations right here in this column, but 8.6 had tropical storm strength winds. To me, that says it was not a Cat 3, not a Cat 2, not even a Cat 1, not a single sustained wind speed exceeding 60.
I believe there was even reports of Cat 5 at some point.
Yeah, it's like, okay.
Yeah,
There were problems with this. I can see, as a former forecaster, I always bumped up to the worst case scenario. It was like, is it going to rain? Yes. You put it out there that it is, because you irritate people if it doesn't. And with winds, I can see them going up a single level. They could have said Cat 1,
Yeah,
maybe a couple gusts in the Cat 2, but 3 levels up, I have a problem with that.
yeah. It's like
So
they took the gusts and just ran with them, the momentary gusts, which last generally, the definition is less than 20 seconds.
right. So we up leveled here by John providing this data, and he gives us these beautiful graphs. And this shows a minimum pressure of 960. And that's low pressure. Standard atmospheric pressures 1013 across the average pressure of the world. You don't usually get storms with this type of a deep pressure. So not saying it wasn't strong. These winds are strong. 60 is not fun at any point. I don't care where you are. 60 hurts things and does bad things. And the wind speeds by sight, it shows there one that hit 60. And here's another one in the 50s, and those were also in the Excel table. But John, can you clarify here? Well, it's probably time to just pass off to you, because you have the live data, the live stuff to show.
Yeah, please make it make sense, and less of a crayon drawing to us. That would be great. Thank you.
So thanks for having me on, guys. I'm John. And
Very well.
from the first episode, or maybe the last episode from Helene, there was a few things that Stella and Jeff pointed out that kind of cued me in on where I could go find this stuff, and then started compiling it. So this is one product that I came up with, and it's interactive. Basically, it's showing us the pressures up here in millibars. All right, so it does look like a bunch of squiggly lines, and then down here at the bottom, we've got wind speeds by sight. We could see this one as it pinged up here, and when we roll over it, it'll tell us at 9:36 local time on the 9th, which I think was Wednesday night, if I'm not mistaken. At Sarasota and Bradenton Airport, it gave us a speed of 60 knots, but then it stopped. That was a weird one. Like it peaked there, but then it didn't report any more data for the night. And the way that I know that is because we can go in here to the data itself and just click on the map here, and it'll show me like it stopped taking readings at about just after 9 p.m. So I don't know if the actual sensor was damaged or something, but yeah. So
excuse me, could I just interject there? I seem to remember that, Jeff, when we were looking at the digits, the black and white data, and there was
Yes.
quite a few bits where there was no data coming through.
Mm-hmm. I had like 5 of those, which I don't think I showed, but
Not
the
all of
data
them, but we
shut
did
off.
look at 1 or 2 of them, yeah.
Yeah.
Interesting. Okay, sorry to interrupt there, John. It just made me wonder if it was the same, probably the same time, I guess.
So we've got here, we're pulling the median number for this data set. All right, so at Sarasota Bradenton, we had 24 knot wind. Of course, we can filter that down a bit. Let me see if it'll behave. And so as I make that graph smaller, we'll see that number rise. And if we were to take this down so that we were just looking at this tiny little window, we'd see it increase up to 60. But over the whole data set for the set of for Florida, we see that the average knots was just 20. Now, of course, it didn't hit down here, right, out in the Bahamas and up in Jacksonville and stuff. So if I were just to select these sites in the middle, still our average wind speed was 21. Now, of course, it's moving across the state, so that's not going to be entirely representative of what's going on. If we were just to select a few here on the West Coast and just look at, we're just basically filtering the data now. And so we can see that over the course of these airports that it would give us higher and lower readings. Let's see here. So anyway, I won't get too in the weeds on that, I guess. But, you know, we've got, let me widen this out. I think the other thing that I might do in the future, or that could be done, is to be able to classify this data. Right now it looks like a bunch of spaghetti strings, and what it's doing is trending the readings that are coming in from the airports. And the definition, the Saffir Simpson scale definition, is whatever the wind speeds are, sustained wind speeds at 10 meters above ground level. And so at these airports, they've got those weather stations set up right about there. And I was talking to a buddy of mine who works in an air tower for a lot of years for the FAA, and he says, "Yep, that's what we look at too. We also look at other data sources, but those two data sources, Jeff, that you just showed a little while ago, AWOS and ASOS. Maybe I forgot that or didn't say it just right, but basically that's what they consider reliable data." And that's all that this spaghetti string stuff is here. It's just bringing that data in and tying it together by site. So here, this site is, so that's St. Petersburg, right? Of course, it got hit pretty hard. I know some people over there. It was just really apparent really quick to me that it was nowhere close to what I was seeing on the news. And it was just very eye-opening. I think the thing that I could do in the future, I meant to complete that thought just a moment ago, but it would be to put the track of the storm in here and then use GIS to offset how far each airport was from the storm and then classify those. I guess I'm getting a little bit techie on this, but how far each airport was from the storm and then classify those in groups of 5 miles or so, maybe 10 miles,
Wow.
so that we could see bands of where it was closest, and then you could filter that data and then, how far. I mean, you would just see classes, like 3 or 4 different groupings of data rather than 100. Right.
Mm-hmm.
That's something that could be done in the future. But yeah, we can kind of see a correlation between the dip and here. So I think this was at Bradenton. Is that right? Yep. It was the Bradenton station.
So what does the dip mean, John? Is that the eye?
Jeff could probably speak better to this.
Yeah, that was the minimum pressure at that airport, which was extremely close to the eye, if you looked at the radar.
Yes, it was, because ground zero was, what was it called again? It was called Siesta Key. It was pretty much ground zero of landfall, so it was reported.
Mm-hmm. There's Siesta Key. Yeah, so Bradenton's right near there.
Yeah, right.
And so at any one of these, I could just roll over the map and show me the lat and long of it. This is Venice Municipal. Our altimeter, our pressure reading, the lowest pressure reading it saw was 973, and then the max wind gust was 64 knots, and the max wind speed it saw was 43. Again, it was just surprising. It was supposed to be a whole lot, the news said it was supposed to be a whole lot stronger. So anyway, the wind gust at Bradenton was 89 knots, the biggest that was in that data set, and the max wind speed was 60 with the pressure at 960. And so with the graph, we're also able to quickly identify where other suspect outliers are. And so they had some action out there at Merritt Island, near the Cape. And where is this guy at? Yep, there's Kennedy, Cape Kennedy. They call it Port Canaveral now.
Oh, okay. There it is.
What were the winds there, John?
Let's see. 58, and 58 was a gust, and 35 was the wind speed, but it was the pressures that were lower. There was also quite a bit of damage down here near Fort Pierce, and I was kind of surprised because I know some folks down there, and there was a lot of damage, but it didn't show in the data. So maybe there was just some old stuff hanging out, and the little bit of wind kind of pushed it over. I had some damage at my house. I live in Central Florida. And so it just wasn't fun for anybody, really. One thing I would also like to look at in the future is storm surge, because that causes damage on near the coast, and that's no fun. Water's powerful force. They got a lot of wind speed at Daytona. Let me see here. Yeah, Daytona International Airport, which is right beside the raceway, is their low pressure was 988, 989, and wind gusts at 76 knots with wind speed 54.
Wow.
Yeah. It's sort of that's the thing. It's like anyone who's walked through a city, and then you've got buildings next to you or whatever, and then you go, you cross a road and there's a bit of an alley, and you feel the surge of wind. I mean, it's very dependent on what's around you, isn't it? So these gusts, impossible to predict, because it could be reliant on things like the infrastructure that's around you, tall buildings or what have you. So it's going to be really random all over the place because of so many different variable factors.
Absolutely. The one term I heard this morning from a buddy was mechanical turbulence. He said even barns can cause it. And
yeah, exactly.
there can be gust on bright, clear days at 200 knots, up in the Jetstream. It's wind gusts aren't totally reliable, but it's an indicator during a storm, right? It's one data point. But Jeff, thanks for early on when I started putting this together, you'd said it's the wind speeds that are the big deal. The wind gusts are a thing, but they're not the most important thing. So we made some adjustments, and the map is better for it. So thank you.
Oh, brilliant. I mean, it's great. There's good minds coming together, and that's fantastic because it builds, a stronger fort. So really appreciate all this. It's
a beautiful thing.
Blessing, manna from heaven. All zeros and ones, like the Matrix manna.
Hey, before we went on, Stella, he was showing me it looked like the Matrix. It was the code that he imported, and it was like,
yeah.
I was just looking for streaming pictures and seeing a woman in a red dress or something. Well, he's I said, how do you know that's the whole United States? He goes, I can just see it.
Yeah.
It was
It's the way
jumbled.
you see clouds. Yeah. So it certainly helps for noobs like me to be able to visualize a lot better. I mean, sure, it does look like a sort of a messy crayon, but the fact that you can adjust it, and refine it, the time spans and what have you, and it just says a whole lot more in a much easier way to interpret than a whole bunch of black and white numbers on a piece of white paper. It's just, much better. People
100 times faster.
Pictures. A lot of people think in pictures. So I know I do. So yeah, very very good to be able to single out so much information. I mean, as I can see there, that every single bit that you hover on or push on is going to tell you something else. So that's brilliant. Very useful tool.
I know.
It's going to be fun to play with, fun to use.
Yeah, 60. They had wind gusts to 64 knots. Now I can see why there was the East Coast. Wait, that's at Sanford. I was looking at Barrow. Sorry to interrupt, but the East Coast hasn't seen a storm in a little while, so I was trying to put together why there would have been so much damage over there. Well,
yeah, I guess you'd also have to look at what the ocean was doing. Like, for instance, when we get the floods here, it seems to often happen at the same time as we're having a king tide. So that's going to vary about how much damage was done as well.
Yeah.
Mm-hmm.
So stuff like that.
Yeah.
And I mean, look at the terrain there. If you just, I don't know if you can zoom in on that a little bit closer there, John, but look at the terrain. I mean, there's like walls of terrain with water behind them. I mean, gosh knows what the currents and things are doing. And I'll just remind people too, again, and I'm going to say this ad nauseum because it really was helpful, is think of the sky as a river. And so, like the buildings, let's just imagine that's a rock and you're looking at the flow of water in a river and it comes against a rock and then it goes round the rock and then there's little swirls, at the other side of the rock because of where the water is rejoining. So, it's just going to be so random and so turbulent in places it may never repeat again, like lightning. So there's a lot of variables. Yeah, if that makes sense.
Makes total sense.
Good.
Well,
Yeah.
Thanks for allowing me to chip in and have fun with this. It sucks about the storm. I hate damage. I hate people losing property and that sort of thing. But it's nice to know that it wasn't as bad as they said it was going to be. And I'm glad that we're able to crunch this data and give another rendering, another opinion on what happened. Because otherwise, I think people would just maybe say, well, it was as bad as the news said if there was nothing else that ever came out about it.
Exactly.
Oh, absolutely. I mean, we're in a propaganda war at the moment, so they have no qualms about watching us, so we're going to watch them. That's what we're here for at the moment.
I like
this
it.
is a fantastic tool. It's a great tool to be on the front line with. So very, very appreciative of you, John, and very glad that you found us and we found you. Thank you.
Yes.
Yeah.
Thank you, John.
Yeah.
Is there anything you'd like to say? Oh, actually, one thing I was going to bring up was the fact that the architecture. It's just funny to watch humans kind of rebuild. It's like, what's the definition of insanity? It's doing the same thing over and over again and expecting a different result. And everyone keeps rebuilding with these rectangles and triangles. It's like, well, try some domes. That idea was, it's been very, not a new idea, but yeah, I think it needs to be looked at a little bit more.
So I can say when I moved to Florida in the beginning of the early aughts, the standards weren't great, and they have made a lot of improvements. And I'm going to stand up for Florida here for just a moment, so deal with it. but the state seems to have really upped their game on emergency management, and there's been a lot going around about how. Well, I won't even get into all that. It's just Florida has become better prepared overall. It was a series of storms, I think it was in 04, 05, 06, somewhere in there. 3 came one after another, and it kind of wrecked Central Florida for a long time, for a few weeks. And after that, I think they learned their lesson. And oddly enough, there are just a few buildings locally that are domes, and they call them hurricane proof. But yeah, everybody's still building the same kind of stuff, but the clips the construction methods are supposed to be better. I can't say that every structure is built to code, but the standards are in place. And so the recovery time is a lot better than it used to be. But still, I hope they learned something from the damage that's been done. I mean, Tampa hadn't seen a heavy storm for, they say, over 100 years. And there's some old legends about Indians and such. And so no matter what, when the tide comes in there any higher than it's used to being, there's going to be damage. There's a bunch of old structures. Yeah, I hope they get it together, make it better.
Yeah, well, you look at a lot of the really ancient buildings too, and they've got domes on them. And I mean, I realise that that's probably an acoustic thing, but maybe it's multi-purpose. Maybe it's a smart architecture as well. Who knows? Jeff, is there anything that you would like to add before we wrap this up?
I think between the 3 episodes, you guys have heard me talking enough.
All right then, we've milked Milton, Milton the monster. All right, but no, this is great. We've got our little kit bag here all set up and ready for battle. So bring it on. We're going to sort the truth out amongst all the field of cowpats and keep at it. Yep, we're watching you. Watching you.
Beautiful.
All right, thank you to everybody who has taken part in today's 3rd wrap-up, our epilogue of Milton. And we'll move on to other things very soon. Please join us for the next episode. And please do a catch-up too if you'd like to find out a bit more in depth about data reading, etc. Our previous episodes on Milton and all the other episodes as well is packed with lots of information. And the way to fight all this stuff is through education. So let's do that. Thank you, John.
Cool. Wonderful being here.
Thank you to everybody else, and any questions, please send them to weather@stellarq.com.au. Don't forget the AU. All right, till next time, take care, everybody. Bye-bye.